The dark matter enigma, the invisible universe.
Look up at the night sky. What do you see? Stars, perhaps a planet or two, the faint glow of the Milky Way. But what if I told you that everything you see, every shimmering point of light, is just a fraction of reality? That the universe as we know it is merely the surface of something far deeper, far stranger? That most of existence is invisible, untouchable, and utterly unknown? For nearly a century, physicists have known that something is missing. The cosmos doesn't add up. Galaxies spin too fast. Light bends where nothing visible exists. The universe, it seems, is held together by an unseen hand. We call this phantom force dark matter. Tonight, we'll drift into this enigma, the greatest unsolved riddle in modern physics. A mystery so profound, it redefines our place in the cosmos. And as we explore its depths, let the weight of the unknown lull you into a state of quiet wonder. It began in 1933 with a man named Fritz Zwicky. While studying the Coma Cluster, a massive group of galaxies, he noticed something impossible. The galaxies were moving too fast. According to the laws of gravity, they should have flown apart long ago. Yet there they were, bound together by nothing. Zwicky called this missing mass Dunkelmatter, dark matter. For decades, his idea was dismissed. But in the 1970s, astronomer Vera Rubin found the same anomaly in spiral galaxies. Stars at the edges orbited just as fast as those near the center, defying Newton's laws. The only explanation? An invisible mass 5 times greater than all visible matter was holding them together. Think of it like this: you're at a party watching dancers twirl in perfect sync. But when you look closer, you realize half the dancers are invisible, their presence only betrayed by the movements of those you can see. That is the universe we live in. So what is this elusive substance? We know it has mass. We know it doesn't emit, absorb, or reflect light, hence dark. But beyond that, nothing. It doesn't interact with the electromagnetic force, meaning it passes through us, through planets, through entire stars as if they weren't there. Some theories suggest dark matter is made of WIMPs, weakly interacting massive particles, hypothetical entities that barely touch ordinary matter. Others propose axions, ultralight particles born in the early universe. There are even wilder ideas that dark matter is a shadow universe, a parallel dimension leaking into ours. But here's the unsettling truth. After decades of searching, we found nothing. Underground labs, particle colliders, space telescopes, all have come up empty. Dark matter remains a cosmic ghost, felt but never seen. What if dark matter doesn't exist at all? Some physicists, like Mordechai Milgrom, argue that our understanding of gravity is flawed. His theory, MON, tweaks Newton's laws to explain galactic motions without invoking invisible matter. It works for some galaxies, but fails for others. Then there's the bullet cluster. When 2 galaxy clusters collided, their dark matter, detected via gravitational lensing, kept moving unaffected. Ordinary gas, however, slowed down. This is the strongest evidence that dark matter is real, and that it's something entirely alien to us. So where does that leave us? With 2 possibilities, both humbling. Either 85% of the universe is made of something we can't detect, or our most fundamental laws are wrong. If dark matter is real, it means we've been blind to most of existence. It means every galaxy, every star, every atom in your body is swimming in an ocean of unseen matter. It means the cosmos is far stranger than we ever imagined. And if we find it, the implications are staggering. Dark matter could be the key to unifying gravity and quantum mechanics. It might reveal hidden dimensions or new forces. It could even rewrite the story of the Big Bang. But if we never detect it, if dark matter remains forever beyond our grasp, then we must face an even more profound truth, that the universe is not just unknown, but unknowable. Dark matter is the first great mystery on our journey tonight, but it is not the last. As we drift deeper into the unknown, remember, some questions have no answers, and perhaps that's what makes them beautiful. Next, we confront an even greater phantom, a force not of attraction, but of repulsion. A power that stretches the very fabric of space itself. Dark energy, the phantom force tearing the universe apart. If dark matter is the unseen hand holding the cosmos together, then dark energy is the shadow pushing it apart. An invisible force, more mysterious than anything we've encountered. A power so subtle, we didn't know it existed until the universe itself betrayed its secret. In 1998, astronomers made a discovery so shocking, it overturned a century of cosmic understanding. They were studying distant supernovae, exploding stars used as cosmic mile markers, expecting to see the universe's expansion slowing under gravity's pull. Instead, they found the opposite. The universe wasn't just expanding, it was accelerating. Imagine throwing a ball into the air, only to watch it shoot away faster and faster, defying gravity. That's what dark energy does to space-time itself, and the implications are terrifying. Einstein once called his cosmological constant, a similar concept, his greatest blunder. But now it seems the universe agreed with him all along. Dark energy is a matter. It isn't even a thing in the traditional sense. It's a property of space itself, an anti-gravity woven into the fabric of reality. The more space expands, the more dark energy appears, creating a runaway effect. Think of it like this: empty space isn't truly empty. Quantum physics tells us it's a frothing sea of temporary particles. What if this quantum foam has an inherent energy, one that grows as space stretches? Or perhaps dark energy is something even stranger, a new force, a fifth fundamental interaction, one we've only glimpsed in the stretching of galaxies. If dark energy keeps growing, the universe faces two possible fates. The first, a slow, cold death, galaxies vanishing over the horizon of space-time, leaving only black holes that evaporate into nothingness. The second, a violent end, where even atoms are ripped apart by the accelerating expansion. Some theories suggest this could happen in as little as 22 billion years. A cosmic blink of an eye. But here's the strangest part: dark energy didn't always dominate. For billions of years, gravity ruled. Only recently, cosmically speaking, did dark energy take over. Almost as if the universe is waking up to its own demise. Dark energy is the universe's greatest unsolved mystery, because it may also be its final one. But before we fade into the endless dark, there's one last place to look for answers. A realm where gravity and quantum mechanics collide in a storm of contradictions. Quantum gravity, the fractured foundation of reality. At the edge of a black hole, where time slows to a standstill and space bends beyond recognition, our understanding of reality shatters. Here, in the violent marriage of the infinitely large and unimaginably small, two fundamental theories, general relativity and quantum mechanics, refuse to speak the same language. This is the crisis of quantum gravity, the deepest fracture in physics. For over a century, two theories have ruled physics. Einstein's general relativity describes the cosmic dance of planets and black holes with elegant geometry. Quantum mechanics captures the chaotic beauty of atoms and particles with probabilistic waves. Alone, they are flawless. Together, they are impossible. At the heart of a black hole, relativity predicts a singularity, a point of infinite density where space-time crushes out of existence. But quantum mechanics abhors infinity. It demands a fuzzy, uncertain core. Who is right? The answer could rewrite reality itself. This isn't just academic. The same paradox haunts the Big Bang's first moments. To understand creation, we must first heal this rift. Desperate for answers, physicists have proposed radical solutions. String theory suggests reality is built from tiny vibrating strings in 11 dimensions. Loop quantum gravity argues space-time is woven from discrete atoms of geometry. The holographic principle claims our 3D universe is a projection from a 2D boundary, like a cosmic illusion. Each theory is mathematically beautiful, yet unproven. After decades, we still don't know if we're chasing truth or mathematical mirages. Some whisper that the answer lies beyond human intuition, that quantum gravity is fundamentally alien to how we perceive reality. The stakes couldn't be higher. If black holes destroy information, as Hawking once thought, then reality's rulebook is incomplete. But if information is preserved, encoded on the event horizon like a cosmic hard drive, then space-time may be emergent, not fundamental. This is the holographic universe hypothesis, that all we see and feel is a projection. That gravity itself is just thermodynamics in disguise. That the stars, are all shadows cast by deeper, stranger laws. Perhaps the most unsettling possibility? that space-time is granular, that if you zoomed in close enough, you find reality is made of tiny, indivisible chunks, like a digital simulation or a cosmic tapestry woven from quantum threads. If space-time is code, if gravity is an illusion, then what else might be? As we cross this event horizon of thought, prepare to question not just the universe's fabric, but its very authenticity. The simulation hypothesis. Are we living in a computer? What if everything you know, the stars above, the ground beneath your feet, even the sensation of this very moment, was nothing more than an elaborate simulation? A cosmic game running on some advanced civilization's computer. This is not science fiction. It is a legitimate scientific possibility, and the evidence may already be all around us. In 2003, philosopher Nick Bostrom laid out a chilling statistical case. If future civilizations develop ancestor simulations, high-fidelity recreations of their past, and if they run enough of them, then the number of simulated minds would vastly outnumber real ones. Therefore, there are only three options. Either intelligent life always self-destructs before reaching this capability, or they universally decide not to simulate, or we're almost certainly living in someone else's simulation right now. Elon Musk puts the odds at 1,000,000,000 to 1 we're in base reality. Even quantum physicists like Silas Bean suggest we might find glitches in low-energy physics, evidence of the simulation's lattice structure. Could certain cosmic anomalies be artifacts of simulation? The universe's pixel-like Planck length. Quantum indeterminacy, like a processor conserving resources by only rendering observed details. Even déjà vu, a memory buffer briefly malfunctioning. Some theorists propose actively testing this. If the universe is rendered on a 3D lattice, high-energy particles might exhibit directional anomalies, like characters in a video game hitting the edge of the map. But here's the true mind-bender. Even if we proved we're in a simulation, would it change anything? If reality feels real to us, does its origin matter? If we're simulated, our creators are neither omnipotent gods nor aliens. They're likely post-human AIs running universe simulations for research or entertainment. Perhaps we're someone's PhD thesis. Or worse, a discontinued prototype. This leads to the simulation stack hypothesis. What if our simulators are themselves simulations in an infinite regression of realities? There may be no base level, just turtles all the way down. If we are code, then death may just be a process termination. But there's one escape even a simulation can't contain. The one force that permeates all layers of reality, consciousness itself. The Fermi paradox, the silence of the cosmos. The universe is ancient beyond comprehension, nearly 14 billion years old. Our galaxy alone contains 100 billion stars, many with planets just like Earth. The numbers say life should be everywhere. Civilizations should have risen and fallen 1,000 times over by now. And yet, we hear nothing. We see nothing. The cosmos is silent. This is the Fermi paradox, the crushing contradiction between what should be and what is. In 1950, physicist Enrico Fermi asked a devastating question. Where is everybody? The answer may lie in the Great Filter, some near impossible step between non-life and interstellar civilization. The terrifying possibility? We don't know which side of the filter we're on. If the filter is behind us, if life itself is a cosmic fluke, then we may truly be alone. But if it's ahead, then every civilization like ours hits a wall. And we may be approaching ours right now. Some whisper of berserker probes, self-replicating machines that sterilize galaxies. Others suggest a universal taboo against contact. Or perhaps the silence is intentional, a test. What if Earth is a protected planet, a cosmic wildlife preserve where advanced civilizations observe us, unseen, like rangers watching animals in a safari park? This is the zoo hypothesis, and it would explain both our survival and our isolation. The rules would be simple: no contact until we reach a certain maturity. No interference unless we threaten ourselves or others. But who enforces these rules? And what happens if we break them? Liu Cixin's dark forest theory proposes a darker answer. Civilizations stay silent because the cosmos is full of predators. Any species that reveals itself is hunted down. Like in a dark forest, the only safe move is to stay hidden and shoot first. This would explain why SETI hears nothing, why we find no Dyson spheres. Because the successful civilizations are the ones we never detect, the ones that know better than to scream into the void. If true, then our radio signals and probes may already be a death sentence. A beacon shouting, "Here we are," to something listening. The Fermi paradox leaves us with two equally terrifying conclusions. Either we are the first, or we are the last. But there is a third possibility, that the answer isn't out there at all. That the greatest mystery isn't in the stars, but in the nature of consciousness itself. The arrow of time, why the universe remembers but cannot forget. Time flows like a river, always forward, never backward. We remember the past but not the future. Eggs shatter, but do not unshatter. This seems obvious, and yet the fundamental laws of physics don't care about time's direction. So why does time have an arrow at all? At the microscopic level, physics is time-symmetric. A video of colliding particles looks equally plausible played forward or backward. Gravity, electromagnetism, even quantum mechanics, none fundamentally distinguish past from future. So why does time feel so irreversible in our daily lives? The answer lies in entropy, the universe's tendency toward disorder. The second law of thermodynamics states entropy always increases over time, creating an objective past, low entropy, and future, high entropy. But this raises a deeper question. Why was entropy so low to begin with? Why did the universe start in such an improbably ordered state? This mystery is called the past hypothesis, and it may hold the key to time itself. The early universe was almost perfectly uniform, a state of absurdly low entropy, like finding a room where all air molecules spontaneously huddle in one corner. This improbable beginning is why time has direction. The universe is still unraveling from that singularly ordered moment. Some theorists suggest this smoothness was caused by quantum fluctuations in an even earlier universe. Others propose a multiverse where only low-entropy universes can spawn conscious observers. But the most unsettling idea? That time's arrow is an illusion, that past and future coexist in a block universe, and our perception of flow is just consciousness moving through it, like a train through stations. Here's the paradox. Time requires change to be measured, but change requires time. So what breaks the loop? Some philosophers argue consciousness itself stitches moments into a timeline, that without memory, there is no past, only an eternal present. Quantum experiments support this. At microscopic scales, particles don't experience time until observed. The present may be the only real moment, with past and future being stories we tell ourselves. This leads to a terrifying corollary. If time is emergent, then entropy, causality, even history itself might be secondary phenomena. The universe doesn't remember or forget, only we do. If time is an illusion, then what are we? Fragments of a frozen eternity? Or something stranger, the universe's way of experiencing itself, one fleeting now at a time? The hard problem of consciousness, the universe awakening to itself. Of all the universe's mysteries, none cuts deeper than consciousness itself. Not how the brain works, but why it feels like anything at all. Why are we not just biological robots processing inputs without inner experience? This is the hard problem, and it may rewrite reality itself. Science can map neurons firing when you see crimson, but cannot explain why crimson feels crimson. This is the explanatory gap. We understand the machinery of perception, but not the miracle of experience. David Chalmers' hard problem asks, why isn't all this information processing happening in the dark? The universe could function exactly as it does with no one home to witness it. And yet, here we are. This suggests consciousness is not emergent, but fundamental. As woven into reality is space and time, panpsychism proposes that consciousness is universal, that even atoms have a whisper of experience. Not thoughts, but primal feels. In this view, human consciousness is just nature's way of concentrating these sparks into bonfires. The implications are staggering. If true, then, the universe isn't just aware, it's self-aware through us. Death may be less like a light turning off and more like a drop returning to an ocean of mind. AI could indeed possess real inner experience. Here's the ultimate twist. If consciousness is fundamental, then it creates reality, not the other way around. The simulation hypothesis gets inverted. Instead of computers generating fake minds, minds generate the computer. This aligns with ancient Vedanta philosophy and modern quantum idealism, that the cosmos is a thought thinking itself, that you, the observer, are the universe experiencing subjectivity for the first and last time. So as we end tonight's journey, consider this: every unsolved mystery we've explored, Dark matter, quantum gravity, even time itself may just be facets of one ultimate riddle. That reality exists because it is observed, that the universe is lonely,